It's 10 minutes later, I go get some beers. Hello, everyone. Hello. I'm Meetup Butchers. We're excited to see you all here. I'm an engineer working for GE Digital. This is our first meetup for the Industrial Internet of Things meetup group. Excited to see the number of people in this room. There's a lot of people on the waiting list too, so there was a lot of excitement. It's great to see all that excitement for even the first meetup that we start for this topic. So we started the idea of this meetup maybe a month ago, and then we decided, okay, let's make it public and send invitations to everyone. And we decided to make this public and see how many people would be interested. The reaction that we got was much more than we expected. It was great to see the number of people on that group. It was great to see the number of people who were interested in the first meetup. So thank you all for coming, and I think we'll get started. I hope everyone had a chance to grab something to eat and drink. So we'll start with our presentation. Our guest speaker today is Jeremiah Stone. He is our IDI, Industrial Data Intelligence General Manager. And that will be followed by another technical demonstration. So let's get started. Thank you. Jeremiah.
Thank you. Thank you so much. I appreciate it. My name is Jeremiah Stone. I am based out in San Ramon, California, in our Software Center of Excellence. And I lead our business that's primarily focused on getting data out of industrial machines, infrastructure, and doing interesting things with it to improve business outcomes and operations. So we call that industrial data intelligence, turning into more how we think about getting those assets to perform, not just being smart about the data, but looking at performance of the infrastructure and what we do. I've got a couple of charts here to walk through, kind of tell our story and where we're coming from, what we're doing. But before I get started, are there any specific questions or thoughts? You know, I mean, you're using your evening tonight to spend with us. I know this is really cool, and I love how they're redeveloping this part of town. Presumably, you have some thoughts in your mind that you'd like to have answered, or specific things you're wondering about what we're doing, or questions. I had some really great conversations before. But anybody have any specific questions that I can tailor my thought? Yes. Okay, so interested in specific security challenges. We do have a live stream here going out on Twitter and whatnot, so I'll just go ahead and repeat that. So I'll look into that. I'll talk about that a little bit.
The industry, not the space.
Okay. Yeah, so broadly speaking, in the industries we serve and the challenges you have. Yeah, okay, sure. Sir?
Message traffic. How do you go ahead and put all these events as well into something simpler? So you have less message traffic.
Okay, so message traffic, how do we think about that? Once you start getting hundreds of thousands of messages, we start to think about monitoring an entire power plant or a set of oil fields or something like that. What does that start to look like?
Yeah, and the fact that that you want to go ahead and try and keep the message traffic within a certain area somehow, condense it, transform it so we have more information messages going out.
Okay, so I'll talk about that a little bit. Probably not going to dive too terribly deep into that, but we can talk about the techniques we use in terms of condensation and passing the data to the cloud, for example, that matters and not move every single byte if they're to do anything meaningful. We can certainly talk about. So security, how do you think about flow of data and managing that more intelligently? Sir?
Standards and interoperability. Nobody gets to own all
Sure. Standards and interoperability, very, very important, and you're right. This is an incredibly fragmented space already, and trying to move forward on that will mean figuring out a place where the community or sets of companies can thrive, and startups and people of all sizes. So we'll talk about that as well. Anything else? All right, but those are very good topics. We'll dig into that. My co-presenter, you get my digits, so to speak. So we can definitely feel free to follow up afterwards and talk. And I'm joined by, as a co-presenter, Steve King will be up here in a little bit. later as one of our leaders within our technical organization to help us go out. In terms of background of people that we have in GE, this really kind of runs the gamut. We have people that have been in the industrial space for decades. We've actually had we've had various software businesses or capabilities in the company for a long time. Software and digital in general is something that has been a fact of life if you're in the machinery businesses. So we have automation groups, focus on HMI, SCADA, that sort of thing. I come most recently to GE. I've been GE for 2 years. I came from SAP, but I started my career at the National Center for Atmospheric Research doing predictive weather modeling. So starting with real with data. We move data in the back of a van, not over a network at all, in terms of getting it from place to place. And you find we're getting all kinds of people coming out of the woodwork that are very excited about this. So I was in the enterprise world, and coming here was just an opportunity to work on things that are neat, and the daily gee whiz factor for us and all the people that are working here is an awful lot of fun. I think you find that. In terms of what's really driving this for GE, it's really at a macro level. If you think about how the company has evolved and where we're going, certainly the global financial crisis and how that changed the capital markets. Capital is a very big part of GE, and refocusing on our industrial roots and kind of figuring out what that means for us as a company was a big deal. So sort of understanding, if you want to go back into being an industrial player predominantly, where 40% of our revenue came from the capital services arm, understanding what that means at a fundamental level was important to us. And one of the things we realized pretty quickly was that innovation and productivity has really stalled out in the last 4 or 5 years from the rate that it was improving on a broad industry basis. And data is increasingly critical from our financial model. A lot of our businesses are based on services after you sell the asset. So the services associated with the jet engine over 40 some odd years, the services associated with a combined cycle plant. And those services are very important, but just like in the auto industry, you can go have somebody plug their computer into your car and tell you what's wrong with it. It's no different in this world. So you have to be the best at working with that for your own business, and it's not too far to think you could do it for others. And the impacts are pretty substantial. So as an example here, if you think about railroad industry, if you can add 1 mile of velocity over a rail network, you can increase earnings by about 20% for that railroad. So we're talking about pretty significant improvements with relatively apparently modest improvements. Where that leads us is into a space where we're not necessarily very good at large-scale modeling, optimization across large networks, also optimization at very small levels, and it leads us into thinking about how we can better run these networks and understand how we can leverage macro trends within the economy. So that this is consistent for us in terms of how we think about our investments. Certainly at the root of it is the physical and the analytical coming together. So how can we model in high fidelity the physical world, and how can we bring data as quickly as possible into that physical operational environment so that you can understand the convergence of your operational environment. Of course, the consistently falling prices of compute, storage, and networking makes an enormous difference if you think about how intelligent you can make an individual asset. And so we start to think about moving, for example, in our control systems for our power plants, moving from a centralized backplane network for managing the plant to a distributed peer-to-peer architecture where the control system is effectively communicating across many nodes in a network rather than in a centralized model. And as that becomes more and more high velocity and higher fidelity, you think about the flutter on an aeroderivative engine, getting that to be smooth, you're kicking off a lot more data. And so with that data, you want to make people's lives better. You want to help them operate machinery better. You want to help them be more effective at operating their infrastructure. And we're facing what one of my customers referred to as grade 2K. In most of our environments, most of the operators, most of the people who are in those environments, we have a significant portion of the workforce that will be retiring in the next 5 years or so. You have a bimodal age distribution. Sir?
So of those four, where are the big knobs? Is it workflow? Is it machinery?
Or where do we get the big payback?
Yeah.
So the question is, where's the big knob up here? I think what we find right now is that the first big hurdle is just visibility. So even understanding the state of your fleet at a fundamental level is very, very difficult. When we see how we tend to look at the progression of where these things go, the very first thing that we're doing, I'd say 80% of the things we're looking right now, is just basically getting things connected into a global point of view. And that turns out to be much, much more difficult and further away than one would expect, given that we have people working on this for decades, so 40, 50 years. It's not like computing is new to the industrial environment. Machine to machine, started many decades ago. Nevertheless, the ability to actually view that data is often confined to the HMI SCADA for the individual system. And often the fleet-wide visibility has been, believe it or not, screen scraping of those HMI screens to even provide knowledge out of it. So the first big knob that we have is just visibility, that people are making decisions on the basis of data rather than on the basis of expertise or practice or opinion in terms of their environment. So people at work is probably the first big knob that we find, is that people make better decisions with data and information. Now, once you have access to that information, you can now start to do some interesting things. You can start to use that data to start to change your operations. And so I'd say, starting with giving the people the data, so getting that data, making it more visible. And then we're starting to see some pretty interesting use cases. I've got a couple of case studies that I'll talk about, is where you start to now take that and have it be something more than decision support and start to close the loop. And you can actually have closed loop control, start with the human in the loop, then move the human onto the loop, and then remove the human from the loop completely. And that's kind of the progression that we're seeing. One of the things that we're very excited about is the ability to bring an ecosystem to bear. So one of the questions, was about protocols, about how do we make sure that there's interoperability standards. We also believe that from an open data accessibility point of view, it's almost just as much of a big deal whether we're talking about IONET, OPC UA, whatever, in terms of wireline protocol, actually having an open architecture from a data point of view, because we know that all the smartest minds in the space aren't going to work with G. Just a lot of numbers, right? The smartest people will not be wearing a G badge. We want to create an ecosystem where that can work. And we're at the very first stages of that. The platform that we're introducing, we're in, I think we go into limited availability in February, general availability in April. And so we're just getting into that phase. We've taken the sort of seeding approach. We've got a community we're working with already, and we're doing sort of early stage hackathons, that sort of thing, to go forward. But really that network effect of smart people with access to the data, the lowest possible barrier to entry, is really where we want to go with that. So, so big knobs, visibility to data. Advanced algorithms, capability to get predictive rather than reactive, change of work process, and ultimately automation. It's a pretty straightforward walk. There's a lot of hard work to do it. The fundamental strategy that we're taking is an open strategy, is sort of, if you want to say, is not a engineered systems approach where we want to own the whole thing and it's going to be something with a monogram on it. Quite the contrary. We're very much looking to use every tool that we have to create and foster an ecosystem of open innovation and collaboration. And we work from seed stage to M&A to large partnering. One of the joys of my job is I get to work with our venture group, and I get to work with Frost Data Capital down in LA, working with early stage startups, working with a team, for example, that's looking at geomagnetic interference on power grids and managing the couplings then down to high voltage transformers and removing that if you start to see patterns evolve where a magnetic storm is actually impacting infrastructure. That's two guys and an idea and looking to get some data, all the way up to C-series startups or major work with Intel, that sort of thing. So it's pretty cool working across this. And I'd say if there were one takeaway across this, what do we focus on? We focus on outcomes. So we're fundamentally looking for the big knob for a specific issue. What's the big outcome? We want to, sort of imagination at work is our tagline. We really believe in that. So we want to sort of own the science and be out at the forefront of these spaces. Is there a question in the back? No? Okay. The digital thread, what we refer to here, is across the entire life cycle of a product or across the entire business process, cutting down the breaks in data across that ecosystem, and then trying to make things simpler and not rely on complicated systems. So as we think about the journey, as we say here, again, data, insights with analytics, and it just comes back to these things. Get people connected, get them insights, and get them optimized. And this is more specifically how we then think about it from a customer point of view, is really foundational investments to sort of free up the data and provide basically an eat-as-you-go model. In the current economy, it's not a rising tide, it's not lifting all boats. It very much is a steady state economy. So any investment, what we're finding with a lot of customers, starts relatively small, and then the returns from that investment finance subsequent investments. And that's really the focus we follow. And so this approach here of helping people move through this maturity curve has been very successful. I think one of the things that we're finding to be true in the market is that pure IT players that are looking at machine learning or statistical-based methods, people that just look at data, and people that have heavy machinery first principles backgrounds, those are incomplete pictures of pieces of the picture. And so I think a secret for success, again, start with the outcomes. When we think about the GE Aviation fleet, our customers don't want to buy engines. They want to buy thrust. They want to buy time on wing. They want to buy planes that are not sitting on the tarmac losing money every day. They want to have higher service levels to their customers. So our contracts tend to be more and more written around time on wing, reliability, decrease of fuel costs, decreasing the maintenance and overhaul schedules. And that then pushes you into a very different world when you're thinking about the systems you design and how you approach this thing. We had a great conversation with Abby earlier, talking about her saying, how do you design your sensoring to be as minimally intrusive but give you the biggest bang for the buck? And that shows up again and again when you think about the key outcomes you're looking at. It's fundamental to the entire business case. It's not a rip and replace, it's an augment. And when you start to see what the changes are happening in this infrastructure, it's a massive change. You talked about open standards. How do we think about open standards? Well, in working in the aviation space, we have a group that's been doing predictive failure on aviation engines. Not the GE group, but a company we acquired about 3 years ago called Smart Signal. Smart Signal comes out of a lot of our research with Argonne National Lab, about 40 years of doing similarity-based modeling on empirical data. And they're working with Delta Airlines for about 14 years now. Delta buys that on top of the condition-based monitoring they get from their customers. And we've been doing that with about a kilobyte of data at flight. You get a snapshot on takeoff, you get a snapshot on cruise, and you get a snapshot when you come down. When you roll up to the gate, somebody comes on the coveralls, pulls out a computer, walks over, jacks it into the wall, and we get the data. Now, with the new Trent 1000 engines, with the new LEAP engines, as soon as that plane hits down, the FADEC starts transmitting. And you're getting, half a terabyte of flight from each one of these planes. You're getting full flight data, allowing you to do very, very different things. But then the question is, well, what are the things you're doing? And as it turns out, the innovation in what you want to do with that data is as much about the business model as it is about what you want to do with the data. For us, there's a very good example of this with one of our engine fleets. The degradation in performance of the engines was diverging from what we had certified with the FAA. That's not a good thing. In case you're wondering if that's a trivial thing, it's a bad thing. And they say you're going to ground that entire fleet. That would be something that would certainly be material to us as a company. But we were able to look into the data because we'd already started on this journey. We were accessing this data at scale. And what we identified was that there was a certain segment of the engines that were showing this degradation. And we were able to compare that with their flight pattern and their city pairs they're going in. As it turned out, this subset of the fleet was flying predominantly to the Middle East and to Asia. Particulate density in the Middle East and Asia is very high. It was a lot higher. You have sand and dust in the air where you've got more pollution, fundamentally. And so we were able to, in an auditable way, show the regulator what the root cause was for what we were doing. And we were able to really protect a lot of the fleet, keep it in the air. But furthermore, we were able to develop a new service. We were able to develop a new business for what it looks like. It's a big vacuum with a hose on the end of it to wash the engines when they come through. So one of the funny things you ask for the big impact is you get pretty rudimentary answers for how to solve these things because you didn't have the data to know when you should be washing these things. And we have one of those that's much, much bigger for combined cycle power plants, also looking at air particulate density and changing your turn down frequency, but on the basis of data, not having to run a borescope, but actually looking at how the machinery is operating. And so a lot of the gems you find and the things that you find out you can look at are relatively straightforward in terms of what you can do with it. Data shaping. This is a good example of the types of things that we deal with from a data density and data shaping point of view. A lot of the work that we do when you're pulling data off of a FADEC on a plugin like this is you want to start filtering on events that matter because it's dumping that full half gig. I don't have to bring a half a terabyte of data back to Chicago where our team looks at this for every flight, every day, for every fleet we monitor. And so you do a lot of local filtering and essentially tiered condensation of the data. The electricity network is another place where you see a lot of it. So enormous amounts of data in the network at the substation level. Say, for example, with synchrophasers, which are effectively bringing the phase of your transmission and distribution into sync, hence the name. We are able to then do concentrators and super concentrators of that data to start to work with it. And that's the data that the geomagnetic guys are working on. But we want to perform analytics where they make sense. And so it's not a hub and spoke model. We tend to want to position the analysis in the system at the point in time that it matters. Procter & Gamble is a big customer and partner of ours, very similar. So there are certain analytics that run at the plant level, there's certain analytics that run at the corporate level, and the data that goes to the corporate level is a tiny smidgen of the overall data set.
So it's a bit rudimentary, but how are you identifying the data that matters? Like at what step are you saying, okay, this is an issue you need to look at more closely?
Yeah, that's a really, really good question. So the question was, how do you know what data matters? And believe it or not, a couple of different ways. And I don't think we know really. We're pretty much in the infancy of figuring this out. I'm not going to claim that we've got it figured out, but I'll tell you a couple of things we do. So when we think about our data science and analytics engineering teams, we've got kind of three main areas of discipline. We probably have about 160 people working in data science and analytics engineering in the company. Doesn't sound like a lot. That's actually an enormous number of data scientists to get in one place. And you have people at our global research centers that are in sort of the machine learning lab and those sorts of things that are working on the actual science of developing the algorithms. We have people that work in the delivery of the product that work in a specific algorithm space. So those people, for example, when we're thinking about doing similarity-based modeling on empirical data, so I need your historical data to create a state matrix to predict the future data, that starts out with all the data. So giving everything you can. At first. But back to the point of how do you move your data and how do you think about managing that appropriately, our goal is to actually reduce the number of tags that we're monitoring, reduce the amount of data we're pulling, because even in this day and age of LTE and everything else, when you start moving this amount of data, it's actually very, very expensive. And so we have continuous improvement and refinement of those analytical models, and we'll drop out tags over time. We'll drop out things to get to the minimal model to be able to perform that. And we actually have 3 or 4 people do nothing else but do analytical improvement. And we also have, we have adaptation built into our algorithms that the algorithm itself kicks out tags and will actually reduce data. So, and the third one, and I'll come back to you. The third one is bring us a multi-terabyte hard drive of data and we'll work, right? And then we apply different statistical, machine learning, physical methods to that data. And we have a whole team that's actually headcount-wise one of the biggest teams we have, which, a customer will say, wow, I've seen the ads, I've seen Owen with his hammer, and I've got a hard drive full of data for you. What can you do with this? And it's a science project, quite frankly. And you end up finding some pretty interesting things. I worked with a large mining operator on their haul truck problems where you have tire blowouts. And as it turns out, the things that correlate and cause are pretty tricky in an entire situation like that. We worked on a project basis over time to apply different mathematical methods to improve that. But it's kind of an all of the above thing, and there's a lot of room for innovation in the space. Sir.
So my question kind of started with the Get Connected slide, but it actually answers this question too. If you're looking for data and you have no idea what you can solve, how do you prove to your bosses what you're looking for? And secondly, what's the time frame that you're telling you can solve this data problem? So you get a percentage on something random that's going to give you some sort of analysis, and you're going to come to an answer that says, I don't know what it's going to be. You have to tell your boss, all right, I need this answer. For what reason? And then what's your time frame that you tell them how long it's going to take you to solve that?
So the business case that you're working on is really, really important. So it's pretty rare that we sort of have the accidental awesomeness of I want to look for this thing and work on it. Usually there is a sort of well-known but accepted cost that people have just grown accustomed to dealing with. And people that have from an intrinsic inability to deal with that persisting, and lots of ideas. And it's just continuous iteration and working on it. But we have found a couple of approaches that tend to work. And the first is isolating the what our sales director calls the total addressable problem. So what is the fundamental problem you're trying to get after, and would the head of operations recognize it as a problem that you would work? That's pretty important in order to get funding to go after it. And then if you understand that, what do you think the value is you could create, and is it significant? And if you could create that kind of value, what's the sensitivity of somebody to be able to pay for it? What are their alternatives? There are lots of big problems that nobody's willing to pay for you to solve, even if there's a large cost associated with it, because there can be perception around an inability to solve that. But once you understand that and you have that nailed down, you can actually do good work. And what we found is that if you jump straight in, you say, no, I'll give you an example, electrical distribution networks, vegetation management. You guys get any ice storm problems with vegetation management out here? I think in the recent storms, it's a big problem. And we had a whole team that spent an entire year saying, we are going to solve the vegetation management problem. We're going to use satellite data. We're going to use drive-by on trucks with LiDAR, Google, all sorts of crazy far-fetching. And it went nowhere. And nobody was really interested in it. And so one of the team members actually took a couple of steps back and said, well, who cares about this problem? Well, it turns out vegetation management for most large utilities is baked into the rate case and is a third-party thing that gets done. There's actually no human being that cares about reducing the vegetation management spend for utility. There is, however, a lot of human beings that care about reducing the cost of restoration from an outage. And so if you can actually talk about how do I solve restoration costs by siting crews appropriately, by cutting high-risk branches and that sort of thing, you can actually do pretty well. It's totally different data, it's totally different analytics, and it's a totally different approach. So understanding, like any business venture, is there somebody who has a compelling need, budget, and so on is pretty important. So another fun use case would be rail. So from a rail point of view, I talked about earlier, 1 mile per hour here, 200 million in savings, a big variety of approaches. So one approach here would be surface robotics as an example.
Can I ask about that number that shocked me earlier when you said 20%? So does that literally mean if I took the average item being shipped from 1 mile an hour faster?
Average velocity across the network, if you look at BNSF or any of those individual, if you look at dwell time, if you look at the fully loaded costs in terms of your rolling stock cost, if you look at your fuel costs, et cetera, these locomotives sit and idle. They burn millions of gallons of fuel. They degrade. You have delays in shipping. You have aggregate shipping costs. And for most of these things, when you actually break it down, it is a linear combination of a lot of things that add up to it. And there's a lot of order. But that is exactly what it means. If you look at the average speed, the average piece of rolling stock across the network, and you could actually bump that. The thing about it, you've got the dwell time on the side, you've got the high speed. It's a very, very complex optimization problem that you deal with when you add in weather, when you add in other types of delays as well. On-site oil analysis. So here's another good example: improvement in sensor and analytics, being able to turn around and answer while you're at site and not take it away to the lab. These are the fun ones. So this is where you really get at that big optimization opportunities. So optimizing your yard operations by actually changing your dwell time and changing when you take off. And then the real fun one on fuel savings is actually positive train control. So it's cruise control for trains that understand the change in the landscape, understand the dew point, the moisture on the rail, and the when to apply the brakes, et cetera. The conductor's still there, but the train's going to drive itself for the most part and do cruise control, understanding the network. I love this one because I think this illustrates kind of where we're going better than almost any others. What you're looking at on the upper left is a LiDAR image of a wind farm. And as you can see, there are eddy wakes coming off of each one of the windmills, and they change where they hit depending upon the wind. And what that does, it actually decreases the power output of the entire farm because you've got these vortices that are traveling through the farm. And so we developed a peer-to-peer control algorithm that actually allows the windmill in the back to say, hey, buddy, you're sending wakes over me, feather your blades differently, and optimize the wind flow that I'm receiving, and also gust response as well. So when the leading edge turbines actually get more of a gust, they tell everybody else and they'll feather their blades. And the interesting side effect of that was that we're able to dematerialize the tower. We're able to take rebar and concrete out of the tower because the shearing stress is less as around. So where are we going with this? We wanted to buy, we wanted to optimize our own operations, we wanted to go. Found there's not really anything on the market that suited our needs, and so we started to build. We're now on our 4th iteration of our platform that we built fundamentally for our own needs to begin with. And along the way on the journey, we discovered that with our peers and other groups, that this is a shared problem. It's much like Amazon built their infrastructure initially to handle their holiday surge and then wanted to rent out their capacity. We want to also provide this to the broader community. And we call this platform Predix. Predix, focuses fundamentally about many of the things we've talked about today for our customers in terms of outcome, and has capabilities, fundamentally geared towards what we find from an industrial point of view. So, when we think about things like security as an example, we have found that, from a security point of view, the challenge in cybersecurity for the industries we serve, think about power. If you're a bulk power provider and you have to live under NERC regulations, or if you're in the medical field and you have to handle HIPAA regulations and you have to actually secure an individual ultrasound machine or X-ray machine, there's a strong regulatory challenge around cybersecurity, but even more than that, there is a strong need to protect these assets, because none of these assets were designed in principle to be connected to a large network where people could access them. And so a lot of the work that we do on cyber is around securing these assets, and a lot of it has to be an add-on. So, some of the things that we have, specific issues that we have is, for example, in the electrical space, some of the attacks that have been developed are much more sort of nation-state level attacks. And so how would you blow up a large transformer? Well, there's actually a documented exploit called the Aurora attack, where you're power cycling very quickly using the standard control system that can cause the oil to heat up, and you can have a failure that way. There are attacks where you can downrate or upgrade the material, cause it to degrade. You don't cause it to fail, you cause it to degrade, so you increase operating costs for your competitors. All sorts of interesting attacks here. And so the type of security you apply to that is actually somewhat different than what you apply in the IT environment, because you are dealing with this zoo of protocols that are out there, and you have to do sort of bitstream level management of the data and apply machine learning to that data to understand what normal traffic is and what abnormal traffic is, and then alert on abnormal traffic. And essentially, it's a defense in depth strategy. Any one approach is inadequate. We have to apply everything that starts at coding standards and doing static testing. We do dynamic testing. We have 2 pen test teams that embarrass people on a daily basis. One of our teams, the red team, is led by VR Akpet, who was previously the head of cyber applications security for Israel, the government. And we take this extremely seriously. And so we went out in the market, said we weren't smart enough. We tried to find the most intelligent, best company we could find, and we bought the company, and all 80 of their employees are now GE badge holders, and more of them now. WorldTech was the company, and they were, at that time, they had set up the Achilles standard for certification of industrial control systems and hardware networks. And now we're basically taking that certification arm, it's no longer part of the company, to remain independent, and we provide services around that. But one of the things we offer is something called OpShield, which is basically a specific piece of hardware that sits in the network and allows you to operate these pieces of machinery on the network without completely air gapping them, so you can actually connect them to the network. Buy it now, sleep well tonight, I think is their tagline. But it's pretty serious stuff, and we take it extremely seriously from a cyber point of view. But a lot of the standard attacks are still relevant. You do have to deal with social attacks, you have to deal with other types of exploits. And some of the standard IT approaches in terms of coding protocols, et cetera, also apply, but you have to deal with wireline level traffic threats, which is a pretty significant difference in this space. So getting close to handing over to Steve here, I think that one thing that's important, and this came up a little bit earlier in terms of open standards and in terms of how do we see this world evolving? We see ourselves providing a small fraction of the applications and work that will happen on Predix, never mind the broader market, and we're designing our business to be in that realm. So if you go to predix.io, that's our website, and you can learn more about what we're doing there. We have an architecture white paper that you can download. It's pretty detailed, and you can learn more about it. As I mentioned, we have the venture arm. We're sort of trying to to spur this leap ahead in any way possible. And our goal is going to be to create compelling, powerful, valuable applications in the sectors that we serve, but do so in a way that we build an infrastructure of data, infrastructure of standard work that works well. So back to your question in a specific manner to standards or protocol. One of the areas that we're tracking very closely is doing deterministic control over Ethernet. And so working with companies like TT Tech out of Austria, who are working on new IEEE standards to basically move that out of the type of vendor-driven, let's say standard by default that we've had in this space into more of an industry standard approach. We also have helped found the Industrial Internet Consortium. I met a couple of people here tonight who have worked with warranty people by creating test beds that work on that. We're also very active in the open source community. So the Predix platform is based on Cloud Foundry. We run on the open source version of Cloud Foundry, and our first contribution back to Cloud Foundry was the secure protocol provider. So back to the question on security, we added the secure router for Cloud Foundry because Cloud Foundry didn't have a secure router for industrial protocols. And so that was our first contribution. People are interested, I can send you the link to track the contribution and page that we're doing there. So very much community oriented, very much an open standards approach, and we're very excited to go down that road. So maybe pause for questions and then hand it over to Steve. Sir, in the back.
So in the aircraft interview, you mentioned collecting all the data is really expensive. Is there any role or trend in the sensors themselves to make them more relevant, to reduce the amount of data that
So the question was mentioned that gathering the data can be expensive. In the aircraft example, is there any role or trend to reduce the amount of data that sensors gather so we can transmit less back to the cloud? Yes, but it's an interesting world, right? So the sensor can produce a very parsimonious with the data that it gathers. But then if you're using XML as a transport layer, you can load up your traffic very, very quickly in terms of the communication. And so, I think this is a space where it's still pretty kludgy, quite frankly, along the way. What you tend to see is layered networks that have data diodes in them, where you have unidirectional network, where you're basically data pumping out of a segmented network to create an air gap in a sense, right? And then, network and data sequestration, and then picking the data that matters and pushing it to the next place. It's not particularly intelligence. I think we'd like to have all the data. I think where we're at right now is a world where we're pulling back the data we think we need to a central location. We're performing the analysis we think we can at a local location. But the vision really is to have real federated querying. And so the ability to have a sharded landscape where you would keep the data locally that makes sense to keep locally. You have a turning wheel and not a sliding window, and you'd manage your data movement by slower, cheaper means. You keep it in effectively a network model rather than a centralized data center model. So if we think about how the global SIM networks are written, there's a lot of math that goes into where the data is staged, because effectively no one place is very good, and you want to be as terse as you can. On the other hand, most of the newer protocols and approaches are not necessarily terse, and we move towards newer standards like OPC UA. We move towards other more open standards. They don't get skinnier; they tend to get fatter. So I think it's probably an area for opportunity. On the other hand, I think that if you look at the different groups and people who are working on this, people are not very mature in their thinking about this either. So most stuff that comes out, more is better, we want more, and people don't tend to think about how expensive that final mile is. We certainly deal with it, but if you look at hot startups that are working in this space, they just don't care. They're pumping away, and it doesn't matter. And you got to be careful. I remember, when I was at SAP, we developed something similar to Ajax probably 3 or 4 years before Ajax, and our CEO said, that's nonsense. We get all of our computers from Dell, and we're never going to have a graphics card that can do all of this local animation. So we're going to do all server-side rendering. And we actually deleted the Perforce branch and moved on, and then had a lot of angry customers that had round trips on every click when everybody else had locally dynamic applications. So it's a really tough thing to predict. Sometimes ignoring it all and being fat and trusting that we all want to spend more on bigger, fatter networks might be the way to go. We tend to have to deal with the parsimony. If you think about all the industrial data that we deal with, we manage that way, but we try not to be, there's a thin line between clever and stupid when you're working on the stuff to quote Spinal Tap. And and we try to stay on the correct side of the line. Any other questions?
For all those that's on the board, what's the primary focus of this data tracking?
That is a great question. So our top 6 industries from a total addressable market point of view in terms of the industries that we go after primarily, and this is shaped in a large part by buying attitude, not necessarily data availability. I think number 1 would be the power industry. So power generation, definitely, is very much up there in terms of optimizing plant performance, optimizing energy. Oil and gas, believe it or not, is still a very big industry. From chemicals industry, downstream is underserved. That would be another one. Food and bev, discrete manufacturing. And then I think the final one, at least in my business, is mining. And that's a big one as well. Aviation is up there also. In terms of, it depends on which application you're going after. Healthcare with all of the move towards cloud-based imaging is very big as well as you go there. So we have 6 we focus on. There's 7 up there, and manufacturing is almost meaningless at that level of granularity because of all the micro verticals. But that's kind of a breakdown in terms of who's investing today. But all of that can flip. And the way these markets move is that if one company gains a competitive advantage by investing in these sorts of things, you tend to see a very quick cascade across competitors. That's happened repeatedly, particularly in the commodities industries, because it's so price sensitive in terms of your productivity per barrel of oil, ton of material, et cetera. And on that note, one of the big movements in mining, for example, is model adaptive control, where you can actually, through fine, high-speed tuning of the control system, you can get more metal out of your dirt effectively, getting 3 or 4% with very good feed forward control and so on, and that's causing a ripple effect within mining in the current commodities. Sir?
I don't know if you pull down the yellow lines. What are they? Is that like a SDK you give somebody? Is that an internet protocol? What is that?
That is a phenomenal segue over to talking more about Predix and sort of what's the platform and how do we think about it and what's provided. Maybe I'll hand over to Steve to talk a little bit more about that.
Sure. Actually, I'm going to give a demo, so I don't know if I need the mic, but I'll start with the mic. We'll go from there. So I'm going to talk a lot about the protocols and the way that we move data kind of from the on-premise into Predix. I'll give a demo of how we do that. I'll show, hopefully this will work. I can show a demo of moving data from my laptop here up into Predix as well. Just wanted to start by asking a question. Who here has heard of Predix before? Okay. And most of the people that raise their hands are non-GE employees, but that's pretty interesting. Who here has used Predix before?
Trying to. Okay, I'm on the wait list.
You're on the wait list? Okay.
It's coming.
Yeah, it's coming.
It's not Christmas.
Keep saying that.
Okay. All right, so I'm going to pull the curtain back a little bit today, give you a sneak peek of what's going on there. I'm going to try to keep it really, really simple. So everything here, that I'm going to show, it's not going to be like an actual airplane or anything like that, but it's moving data, and it's basically the foundations for building on top of and to enable the industrial internet vision that we're looking for. So, with that being said, let me see if I remove the mic. Can everyone still hear me? Yeah. I'm going to kind of show a little bit. Okay, good. All right, so I'm going to, as I move forward with this demo, this is actually the second time that Jeremiah and I have done this demo. The first time we did it in London, and the big plan was to bring some industrial equipment to the UK and to show this grand demo. Unfortunately, there's export restrictions on our equipment, so I couldn't do that. And I actually didn't bring it here. And I work in Foxborough, so I have no excuse for not bringing the equipment in here today. The next time we do it, though, I promise we're going to have some industrial stuff. But I look at the way I want to do this demo. Now, hopefully, I get through step 1 and step 2 tonight. But over time, I want to get to this analytics, and I want to be able to do this kind of from scratch in about half an hour. I want to be able to, from scratch using Predix, get connected, visualize the data, push data from some actual real device, model the data, and then introduce some simple analytics. And I think it's possible, based on everything that I've seen in Predix so far. I think it's possible to do that. And I'll show 1 or 2 tonight, and we'll have follow-ups, and we'll get there in the next couple of months or so. So what I'm going to show is a demo. There's a couple of things I'm going to show before this, but this is really the basic architecture of what I'm going to show. Jeremiah talked a lot about our contribution to Cloud Foundry in terms of unified authorization and access control. So that's kind of the foundation here. I'll show a system that leverages that service. It also introduces a time series service. So who here works with time series data? Great, great. So actually, I manage a team in Foxborough that we work on Historian, which is an on-premise time series product. Has anyone heard of that? No? Okay, great, great. So yeah, we have thousands of installations, internal and external to GE. We collect data at high speed. We store it in a highly compressed format, and it's really for industrial applications. We've been doing that for about 10 plus years or so. So I've actually been on the team for about 5 years. And so I have some industrial data experience now. Before that, I actually was not in that industry. I worked for a portal company called Humphrey Software before that. So, so you don't have to have an intense industrial background to get in this space. It's really open for everybody. Anyways, back to this. So we have a time series service. Now this is the cloud time series service. The Historian product is on premise, but we've really helped that team develop this time series service, and we tried to transfer a lot of our industry knowledge towards that team. So we're building it in a way that makes sense. We also have, I'm going to show the deployment of a Spring application, and this is a very, very simple application. Just has a chart on it, and you use the browser to view the chart. And I'm going to create a WebSocket connection, and it'll be a secure connection that can feed data into that time series service. This is all using Predix, and I hope I can build all this from scratch in the next couple of minutes. All right. So just to give another introduction, if you go to predix.io, and anyone can go to this site. This is where you register for an account and get on the wait list. You can actually, without even logging in, you can view the catalog of services that are available.
But you have to be on a wait list.
It's in closed beta.
Yeah, we're in a closed beta.
Nice.
But over time means here in the next couple of months. It's not like years here. We're moving because the limited availability in February, and the plan is in Q2 to open up to general availability and free trials.
All right, so predix.io, if you go to the catalog, you can see the different services that are offered via the platform. There's a reference app. I can show a quick demo of that before I get into creating our own here. And there's another dashboard app that basically gives you a GE dashboard. We have a machine software that runs on the edge that can collect data. Here's the time series store that I was talking about before. Level 3 of my demo would be to introduce the asset data service. Should be great. That'll be a follow-up. It's a lot of different services. The final piece of that demo could be introduce some of these analytic services into the demo and build these kind of in real time. Here's the UAA service right here that I'll use in the demo. We have ways to create kind of standard views, workflows. If I go to the time series service here real quick. And go to the documentation tab. I just want to talk a little bit about how industrial time series differentiates from kind of regular time series data. Industrial time series data, really probably the primary differentiator is a quality attribute. You'll see that a lot of time series applications that are available in the cloud today don't really introduce the quality attribute. And it's an important attribute as part of the OPC specification. So, it's something that we built right into the platform. And it's important to build it into the platform kind of from the very beginning, because quality as kind of a third dimension of your data needs to be incorporated into all of your interpolation algorithms. All the software that's doing interpolation of the data to make it easier to visualize. If you don't introduce quality into those algorithms, it really needs to be done at a fundamental level, or else you're going to have really big issues with performance. So if you go to using the time series service, you'll see that data quality is built right in. So you have different levels from bad quality to good quality. All right. Okay, so let's try to deploy this application now. Talk a little bit about what it's going to do. I have a script here that basically automates all of the steps in order to set this all up. So that, again, this is creating a UAA instance. It's creating a web application. It's creating a time series instance, and it's kind of wiring it all up together, deploying it out to Cloud Foundry, and making it available. So. All right, so it's going to create a new space in Cloud Foundry to start. It's creating the UAA service right now. This script assigns a new identifier to all this. So every time you run the script, it will actually create a new, totally new environment. Been working on this for a little while because it's a little tedious to get all this set up by hand. So I wanted to automate the whole process. And it builds the web application. Again, it's just a simple web application in Spring that has a chart in it that will show the data. It will push the app to Cloud Foundry to create. It takes about 2 minutes or so to run. Any questions so far while we run the script? Yep.
There are Python bindings for computer services as well.
Right. I just use Ruby to just do the automation. It's just an easy tool to use on a Mac. So you could use Python to do the same thing.
Yeah.
It's really just automated in Cloud Foundry commands. I also use
bindings in the platform itself.
Right. Well, you can use any kind of WebSocket client to push data. The services you deploy are Java-based services. So you could write, you can use a Python WebSocket client to push data. We also have machine software that, you can use OPC UA, send data.
I think one of the things that's important here is we want to try to help people focus on value additive stuff, and that's kind of the goal from our point of view. And so we're going to show the data streaming off of an emulator that goes into that, but what's important is that the entire infrastructure that this uses would be deployable to a power company. It would be deployable to an industrial company in terms of the amount of heavy lifting that goes in getting it there from a verifiability, from a security point of view, et cetera. Within the analytics environment, today we have containers for MATLAB, R, and Python as the initial analytics runtime. And we're waiting. We've got a bunch of stuff in .NET. Let's face it, that's what the industrial world has been writing in, and so we're working on looking at either Dockerized versions of .NET containers or .NET container itself for running on the platform in case you've got a killer app already and you wanted to then move that with as little refactoring as possible.
Okay, so everything built, it's actually pushing the Cloud Foundry now. I can run the app locally. Right now what I'm doing is I'm using a Node.js WebSocket client to push data to my time series instance. So every second it's sending a message.
What kind of data is this?
It's basically time series data, so it's a timestamp and a value. It's just a random value between 0 and 1.
Is it sensor or something like that?
This is just random data generated on my laptop right now. So that's like the next level.
Yeah, this afternoon in the office, Mina had a Raspberry Pi hooked up with a temperature probe or something, and we're going to look at that. And then we're talking about bringing maybe a reciprocating compressor or something in and introduce a failure and watch it flutter, watch it move. So that's the next Meetup. But in principle, you know, the types of data you look at, the emulation of that here is effectively pretty straightforward. And from a demo value point of view, you know, definitely taking a temperature probe between the beer and the coffee is cool. Or looking at hundreds of thousands of writes much faster. I think that's probably more interesting is if we start to look at the high speed writes and things like one of the highest speed situations we deal with is diaper folding machines of all things in terms of the velocity that comes off.
All right, so I'm running this locally in a Jetty container. I can push it to the Cloud Foundry, so it's hosted in the cloud. Actually, that did actually just happen, but I'm going to run locally first. As you can see, when I tried to go to my local website, it redirected me to the Predix login screen. So this is all, the script that I ran integrated all the security into the time series service and the website itself. And when I sign in, I'll authorize the clients, and it should show the data that I'm pushing. There we go. So it's a live chart of data that I'm pushing. Again, this is all done from scratch using Predix tools and the Predix platform. So it's like about 10 minutes or so to get started. Very, very basic, very, very fundamental, but I think it's a building block for doing more interesting things as we go forward. Any other questions? Yes. That's a great question. This sample is not available on the website, but let me show you a little bit about what is available. So we have a GitHub for Predix. So one of the, we want to build a community of developers and engineers. So moving to GitHub is a big deal for GE. I mean, we've been kind of closed source for a really long time. So now we're building community developers.
Closed source and old school source.
Yeah, old school.
So we got a clear case instances for SVC and stuff.
Absolutely. So this is the Predix GitHub site, and when you get access to Predix, you get access to this. So there's all kinds of stuff out there. I will put the code that I showed here. I developed that over the last couple of days. I'll get that out there in the Predix GitHub site. So if you have access, you can go and download that. I mean, it really is a good reference app because it gives you everything you need to know in terms of, for instance, using the Node.js application to push data, how to get a token, how to pass that token to the server, how to retrieve the data back. So this is a great reference example for that. In Spring, how to configure Spring for single sign-on against Predix. This is a great reference app for that. Let's see, how to on the server, how to call the time series service, and how to provide authentication and authorization of the time series service, so that you can retrieve time series data back and show it in the chart. So I will get all this information up there.
Want to show the R&D reference app?
Yeah. So if you build upon this and introduce analytics and introduce a model into it, this is something that this might be one of the next levels we get to. So this is our reference app. All this code is available on the GitHub site of Predix today. This introduces an equipment model, which is the context, and you can navigate the equipment model. And when you get to an asset, you can open the asset and you can basically, view the KPIs on that asset. Are there any alerts on it? So there are actually analytics built into this UI. There's more visualization here. You can add multiple KPIs to the chart. So, you can change the time range. It's a pretty decent reference app, sample app.
This is one of the areas that we're focusing on the most is the availability of UI widgets to build off of. It's actually where Predix started. It was the first thing we shipped was the what we now call called P.X, which is the design system. And it's based upon a lot of in-the-field ethnography with industrial users and working with them to find out what are the specific things they need to look at, what are interaction patterns to work with and to kind of design it. And then, we hope to be a significant barrier to lowering, quality applications that people build on that, because you can just pull in, UI widgets and not have to build things from the ground up.
So hopefully that was enough information about Predix. Any other questions, any other thoughts about where we're at?
Yeah, question. It seems like you're trying to address a lot of different actors in the space. Could be someone in industrial engineering, a plant process, could be someone manufacturing, headquarters doing large scale data analysis. Do you guys have personas that people you're trying to serve with the product and the platform? And if you do have those, what would be your top 3 personas in the prototypical person using the platform?
I think we're mainly gearing this towards a lot of OEMs and third parties that build platforms on top of. We built kind of the first large-scale software package on top of Predix. It's called APM, Asset Performance Management, and that's really for on-site monitoring and diagnostics for kind of the control room to monitor assets. We have some very large monitoring facilities, particularly in the power and water space for power generation, and we've been working with them closely. As Jeremiah noted, they're really our top market, and within GE, there's a huge business around that, and so they're definitely heavily involved in the development of this platform, really for the OSM on-site monitoring.
Yeah, it's a kind of the way that, so for my business, about 20% of my business is the GE businesses, 80% are direct to market, and about half of that business today is really just helping people get connected and understand their data. About half of it is advanced analytics and doing predictive analytics and so on. And of that, that's predominantly focused on the remote monitoring and diagnostics of existing fleets. And the predominant business case there is cutting your operations and maintenance spend. And the legs of an operation and maintenance spend, you've got inventory, order the wrong thing, order too many of them, they sit on your shelf, tons of waste. I spent 4 days on a drill ship in the Gulf of Mexico earlier last year in April, and they had $14 million worth of inventory on that one ship. It was out of a fleet of 100, right? So that's a lot of waste. Think about wrench time, think about the first time fix rates, those sorts of things. And that's really sort of the immediate place. But that's not really where the benefit is. And the benefit predominantly is really when you start to optimize operations, when you start to optimize business processes. We're sort of bootstrapping our way to those high value applications. But to go back to mining as an example, the equipment health piece of that is probably about 20% of the total value you get after. And that's definitely the case. If we start to think about power, back to power, the majority of the value is really in operating the plant differently. But you can't get there until you kind of walk through the pathway of the equipment health piece. I would say healthcare is probably our biggest outlier in that respect, because they're really focused on the imagery, and their business case is sort of being able to take that imagery to the right expert anywhere in the world. And so using the cloud very differently in terms of making sure that you don't have such a co-location of the doctor with the patient. You can actually take it to the specialist in that field wherever they are while still managing that data. So that's a pretty big deal for the healthcare cloud as an example there. Interestingly enough, though, healthcare colleagues say, oh, we don't have this problem with assets, we don't have this problem with assets. Well, it turns out it's because the services group was not talking to us yet, and I just talked to the services group and said, oh, you would know how much we spend on packing tubes and magnets and stuff, that sort of thing. So yeah, it's interesting where you find the opportunities to help, and a lot of it's cycle time reduction in terms of how you do work. There's a lot of dwell time in all of these industries, and there's just a huge opportunity. And we talk about small increments, but we really think it's double digits. It's 10, 15, 20% in terms of improvement. A lot of that is closing the loop, so you have a tight control loop. And that's why, the deterministic Ethernet is so important, which is, finding its way in cars and automotive. So as we get the self-driving cars, the cost comes down on the control systems and the network, the IIoT. We're doing deterministic Ethernet, and then you can really take it to the cloud, build new models, push it back down, and then have closed loop control.
Who's connecting the mind? Who are the companies that are going in and putting sensors on the equipment? Is that manufacturers of the trucks themselves? I feel like I'm missing who that middleman is.
So
Actually,
it's a lot of different people, right? And I kind of expected to see some of our ecosystem partners here tonight. We actually have a couple of folks here. Automatech is a local company that we work with. There's a strong third-party services component here, people that specialize in the systems integration and deployment. There are the manufacturers of the sensors, so the OEM manufacturers. Then there's also sort of the big consulting firms who then tend to subcontract out to vertical specific providers. So a lot of sort of the big IT firms, Deloitte, Accenture, et cetera, are building practices in this space, and they tend to work with people who tend to become mom and pop shops, and they're relatively small, micro vertical specific folks who really understand a specific subset of equipment and so on, and they do that. So it's a really interesting space in terms of volume, kind of greenfield market in terms of providing these services, and the technology is moving so quickly that incumbent vendors don't necessarily have an advantage because everybody's learning as we go. So you're missing it because it doesn't really exist. It's happening right now. Sir? Competitors?
Yeah.
That's a great question. Most competition that we see today in a deal-by-deal basis is very regionally and segment-oriented. We tend to see people who are mining specialists in sub-Saharan Africa that are local providers. If we look and project and go out, I see there are many companies chasing this opportunity. Certainly, long-time industrial equipment companies who play in the same space as we are. Your ABB, Siemens, Schneider, those kinds of companies. It's definitely an opportunity. I think a lot of the incumbent IT providers, so IBM, SAP, Oracle, the usual suspects. But I don't really think about those companies as our competition for what we want to do. I tend to think about the companies I don't know exist. I think this space is in such a rapid moving forward space that we don't know who are most dangerous from our own perspective. We want to build an ecosystem that's friendly. But certainly there's a lot of opportunity here from a business perspective, and where the space is today in terms of its nascent evolution, I don't think it's really clear who's going to lead the space. We're certainly putting a lot of capital behind winning, and we're very intent. This is really about the transformation of GE to be a digital industrial, to be a fundamentally new kind of company. It's not an industrial company that has a software subsidiary. This is fundamental to all of our groups, and that's really important to us. But in terms of competition, I think that it's still evolving very, very quickly, and there are various providers for various applications. But in terms of the different opportunities that we're seeing here, I think it's a pretty open space, and a lot of people trying to invest and do well. But it's an open place, and I don't think we know necessarily. It's going to be innovation idea, and it's super exciting. Sir, in the back.
I saw some AWS and URLs, and I was wondering about is there any kind of obviously the partner using them? Is them a competitor if they're new IoT offering?
No, that's a great question. So you saw AWS on there. I mean, as a Cloud Foundry user, we can deploy into different environments, and so we're using AWS for some of the early development version. We will be running in colos on our own hardware, so we're building out cloud centers at the moment, not building data centers, so we're kind of running a middle path there. I think at the moment, we're playing in different markets fundamentally. So AWS really from an infrastructure as a service point of view. So what you get with AWS is much more raw, right? You're getting machine image. Yes, they provide a degree of services, but you're really getting building blocks that are more fundamental. We're much more focused on a platform as a service. And so what we're providing is very finely tailored to just industrial companies in general. And so a lot of the things that Steve pointed out, in terms of the security protocols we're using, in terms of machine learning on security at the device, at the edge, is very different than where Amazon is focusing. They're much more in a broader space. So they're a strong partner. I mean, if they were to double down and go out this space, it's possible. It's certainly possible. But today, I'd say we're playing in two fundamentally different markets. And if you were to come and you're shopping for an open infrastructure environment, it's just not what we're doing. And so that kind of a buyer would be choosing between, Azure, Amazon, Google, et cetera, and would not necessarily be looking at Predix. Predix is really for people that are looking for applications and building their own applications on top of a pretty sophisticated stack already, and not just an OS level. That's the way I see it. I don't know, Steve, would you agree with that?
Yeah, I totally agree. I mentioned quality before. Amazon does have a time series service as well. But again, it doesn't have quality built in. It doesn't have the industrial algorithms for interpolation built in. So, you have to build all that on top of it.
There's tons of time series stuff done on Amazon, right? Clickstream analysis is a huge set of time series data. There's a lot of innovation there, but a lot of the algorithms and workbits that's done on that day is not applicable. There's fundamentally different entities. You think there's this sort of consumer, enterprise, and industrial, and these are kind of fundamentally different marketplaces for at least as we experience it today when we're in it. I'm telling you, deal cycles on the business, so I see a lot of RFPs, I see a lot of play, and it's just not something we see a lot today, but who knows what the future will. Sir?
So this is a dumb question, can you give me a little more insight into the architecture of the top series services?
Right. Yep. So time series service is built on top of Cassandra. Cassandra, which is a columnar NoSQL database. There's another layer of open source on top of that called Kairos DB. So we've taken Cassandra and Kairos DB, and then we've modified that layer to create our own kind of instance of time series service. We wanted to leverage what was out in the field. There was a long discussion that went on about our existing technology in time series and whether it was applicable in kind of a cloud-native environment. At the end of the day, we chose the open source route. So there is still a gap in features. If you did compare our historian product, which is on premise, and the cloud product, but we're steadily and quickly closing that gap, and they'll be feature equal in the near future.
So let's say I have some device that I actually call scaling. Could I actually write some kind of sharing code between the service and
Oh, we have, there's a couple different things you can do there. We have a lot of different ways to connect. So I wrote a little bit of shim code there in Node.js that generated data. You could use something like that. We also have machine software, which is on-premise software package that you install that can leverage OPC UA. It also can read Modbus and send that data to the cloud. And then also our historians that we have today. We have thousands of historian customers out there. We wrote something for historian called the Server to Cloud Collector. That is a very small piece of software. You install it on your historian, and it configures a new kind of distributor for historian that pushes data straight to Predix. So there's a lot of different ways to send data. And again, it's a WebSocket-based infrastructure. So if you did want to write something custom, you could. What you're missing out, I think, when you do that, there's a lot of aspects of industrial time series beyond quality, even like store and forward, right? And what do you do when the connection goes? How do you manage that store and forward software? Stuff like that you need to account for.
And I think that field agent that Steve's talking about is really important in terms of sort of the edge node between that system and what we're talking about here. And what we've done is we've taken around 400 drivers and collectors from our own SCADA HMI business as well as our historian and package those up. So it's a plug and play as close as we can get. And then there's other third-party driver and collector providers like Kepware and others that are able to provide that. And then that basically plugs in to allow as easy a connectivity there. I mean, we don't want people recreating the wheel to write those kind of shims and stuff. It's not value additive. There's good data out right now, I think just released by IDC, that says about 85% of a data analytics project is spent on that kind of stuff, right? So spend on data wrangling, just getting the infrastructure in place, and only about 15% value add. And that's kind of our goal up front, is to just get rid of that and allow people to focus their resources on building, better applications. And so what we tend to expect and believe is that, if you take, for example, the asset performance management capabilities that is part of the business I'm responsible for, one of our key applications is called machine and equipment health. So out of the box, connect all those assets, route it up into the cloud, show the capability of the fleet at a ratable service-based price. But then the opportunity for the ecosystem is to come in and say, great, now I've got a microservices architecture, I get access to that API, and I can build a value-added app associated with that, or you can utilize some of the same underlying resources to get there and have a standalone application as well. If you are not using Predix, you're not using that, you're going to have to go through every single step along the data pathway and replicate that. And we've got, some partners that have considerable resources. They're thrilled, quite frankly, that they'll be able to leverage this. And so it means a significant sunk cost on our side, but we're hoping that, knowing just how the drudgery of doing all this low-level stuff, taking that out of the way, that we can unleash a lot of creativity and benefit. Pretty straightforward, right? Other questions? Sir?
What about machine learning?
That's a good question. As I mentioned, the containers in the Predix Analytics package, today we support, let's see, over here, so in terms of analytic services, the analytic services catalog is a catalog of different analytic types that you're able to access and then utilize within Predix. And a lot of the analytic services that we're providing today, if we go back up to the catalog here, the services that we're providing today, there are machine learning services provided by, for example, anomaly detection with Theta Array and some of the other services. One of the discussions we're talking about in terms of our own internal machine learning and even statistical machine learning capabilities that we've developed at proprietary, actually pushing them down into the Predix layer and opening them up. At the moment, we don't have any in the catalog. That would really be a container, bring your own, and drop it in either in R, in Python, or now those sorts of packages. But one of the challenges with our existing machine learning capabilities is that they're built and they have basically set linear processing, and so they're set up to do a very specific thing, and it's kind of core to the application or business that applies them. And so we're going through a refactoring exercise right now. We're effectively granularly breaking those up and making them available as microservices and available for orchestration. And then it's going to be a business decision on our part. We got tons of patents around these things, and it's some advanced, sophisticated stuff. Then we need to decide for us, is that going to be something that is consumable from the market, or is that something that we want to keep as secret sauce? And we haven't crossed that bridge because we're not refactored yet, and they're kind of two separate things. We're committed to refactoring everything to run in this environment. And then secondarily, what you'll find is there will be a catalog that's available at the base sort of utility rate pricing to run on this, then sort of a premium catalog that will be available in addition, and then probably a catalog that people use only in their applications for delivery of their services, and then differentiate on the services. So it's going to be a pretty interesting space as it plays out. I don't really know what the economics look like over time, frankly, because nothing like this really exists. And we're going to learn as we go, and we're trying to be unambiguous about putting an awful lot of value on the table up front for economics that are pretty disruptive compared to what you have to pay today, but also careful about IP that we've invested a significant amount of capital in as well. So that's a thing that we're crossing as we go down the road. So longer answer than the initial question, but it's an important question. Sure.
Do you have a sense of, is the business model 100% service, or is someone going to be able to license this and then
At the moment, we're looking at 100% service. In terms of perpetual licensing, it's not something we're really looking at. In terms of private clouds, I think there are probably some exotic cases where, we're going through that discussion where government data provenance, et cetera, or, for example, in the Chinese power industry, it's actually regulatory requirement that you can only run within the power company's network. So you couldn't even push updates, so the entire DevOps model breaks, right? So those are things that we look at commercially, but the core of this is, cloud service ratable as a fundamental business model. Even when we have, it's a hybrid. Everything you saw, obviously we have a lot of on-prem capabilities here, but we're basically moving towards that service ratable model. More questions? Okay, Mina, all yours.
Thank you. All right. Mention one more thing. We want to thank you all for coming. This has been very interesting to see that number of people here again. I just want to mention that GA Digital is the sponsor of this event and this meetup. So I'd like to thank GA for that.
I'd like to thank you all for coming in. I know it might not be easy coming in one day like that. Just want to run a couple things with you. So this meetup, we have an open hub for collaboration and exchange of ideas. So if you have any topic that you are interested in, please let us know. If you want to present or you know someone who wants to present, let us know. Also, we wanted to do the kind of like mixture between what you saw today and also thinking about workshops as well. So let us know. We'll put up a couple ideas and we'll see. Thank you.
Thanks a lot. Thanks again.
Thanks so much.
Nice job. Steve, Chris Campbell, President. I want to talk today about third-party ecosystem. We have presentation-led collaboration solutions. You guys do that. So we have an environment to help bring teams together, have a better but then also visualizing all this data. This could be data. So there's 100 value connected down to displays of any size. So it's sort of like not video content, it's content. So you apply this to so, yeah, you have to,